Okay, today we're just going to do a quick review of graphing linear equations. Remember that linear equations, the word linear has line in it. When we graph linear equations, their graph is a line. So, if you're working on linear equations worksheet and you have something that doesn't look like a line, that is probably a problem. So, we have to know multiple ways to graph linear equations. Just knowing one way isn't going to be good enough because it won't work in every single situation. So, the most standard way to graph a line, and what I'm sure you learned first, way back in Algebra 1, is that of using slope-intercept form. Whoa, my pen went a little crazy there. My S is all nuts, but that's all right. So when we're looking at slope-intercept form of an equation, that means that in general, it can take the form y equals mx plus b. Remember that m is your slope and b is your y-intercept. If you don't know what a y-intercept is, that means where the line crosses the y-axis. When we're looking at a graph, this is our x-axis, this is our y-axis, so a y-intercept is the point where your line crosses this axis right here. So slope-intercept form, if you have it nicely lined up like that, it's great. Let's say we had the equation y equals 3/4 x plus 2. So if we look at that equation, it does take this form. We've got y on the left, we've got a number, then we've got x, and then we've got another number added on the end. So this would mean that our y-intercept is 2, our slope is 3/4. So I often will ask you to write this, not because it's required and I'll mark it wrong if you don't, but because I love to give partial credit. So if your line is wrong, but you wrote down the correct slope and intercept, I know that you knew something about how to graph it. So every little point counts. So B is begin. So the B is where you begin. On the y-axis, it's a positive 2, so we begin up 2. The M, slope, is how you move. M for move. B for begin, M for move. You move, and it's rise over run. No, you've seen that before. Rise means up and down, run means left and right. So we are going to move up 3 units and then right 4 units before we make our next dot. And we continue in that pattern until we're off the graph. Up 3, right 4, right on the end. Now, if you have room, you should continue, if you have the slope and the intercept, making dots till you're off the page, because remember that 3/4 can mean up 3, right 4, but it can also mean down 3 and left 4. Down 3 and left 4. So your line is going to be more accurate if it goes all the way across the page. So it should go all the way across the page in your homework. Trust me, it's much harder to draw on this than it is on your paper because your paper is flat. This is not. So hopefully your lines look a little better than mine, and they actually are straight rather than curved. All right, so another thing that I want to point out as we are graphing slope-intercept form, sometimes the equations that you are given are not already exactly looking like slope-intercept form. That doesn't mean that you can't use slope-intercept form to graph it. Let's say that I had the equation 2x plus y minus 14 equals 0. This equation is not currently in slope-intercept form, but it very easily could be. To be in slope-intercept form, we need the y to be alone, so I need to move the other ones, much like when I'm solving equations. So I would need to subtract the 2x and add the 14 So y equals negative 2x plus 14. Now this comes to another point to review. 14 is off the page. Unless it's like one space off the page, please do not try to extend the graph. There will be cases where you're working on assignments where you are not allowed to extend the graph. So don't extend the graph. Just count by something other than ones. You don't have to label your scale on this type of a graph if you're counting by ones. But if you're going to count by something else, go ahead and label it. So here I would need, twos would be plenty. I'd be able to fit twos on there. You don't have to use the same scale on the x-axis that you do on the y, but I usually do unless it's a word problem where the difference between them is really big, like if your y is going up to 100,000 and your x is only going up to 10. Then you would use a different scale. Here, there's really no need to. Plus, if I use the same scale on both of my axes, I can still use my slope movement in the same manner. So I'm going to show you what I mean. So y equals mx plus b, my m is negative 2, my b is 14. So again, my b is where I begin, so I'm going to start up 14. So 2, 4, 6, 8, 10, 12, 14 is right up here. Now, a slope of negative 2, since there is no denominator, that means negative 2 over 1. So that would mean down 2 units, right 1 unit, or you could go up 2 units and left 1 unit. So this is what I was talking about when I said if you use the same scale on both axes, you can still count slope, even though you're not counting by ones, because I could still move down 2, right 1, down 2, right 1. Now, you might say, well, wait a minute, Mrs. Thomas, but you're really not moving down 2 and right 1. You're moving down 4, so negative 4, and right 2. Well, let's take a look at these. Negative 4 over 2 and negative 2 over 1 are equivalent. They're the same. So that's why if you use the same scale on both axes, it doesn't matter what your scale is. You can still just count units with the slope. Now, just be careful, because in the event that you don't use the same scale, if you try to count in this manner and your x's is going by ones, it's not going to be right. So just pay attention to what you're doing, but I usually try to use the same scale if at all possible, just to make it a little easier. Also, now is a good time to point out positive slopes. So if your m is positive, they rise to the right because they're getting bigger, they're getting positive. Negative slopes fall to the right. So as we look right, they are going down. All right, so that's good for slope-intercept. The other really important form of a line that you need to know, not just for graphing, but also for writing an equation of a line, which is another important Algebra 1 skill, is point-slope form. Point-slope form, and if you think you don't know this, again, you should be writing this down. You can draw your graphs by hand, but really important that you know this. So if you can't tell me right now what point-slope form is, you need to write this down, keep it in the front of your binder or folder, because this is important that you know this. Point-slope form is y minus y1 equals m times x minus x1, where m is your slope, and x1, y1 is a point on the line. The reason why I say this one is so important, and perhaps even more important than slope-intercept form, is that most of the time when you're asked to write an equation of a line, you don't already have both the slope and the intercept. You might have 2 points. You might have a point and a slope. If you have 2 points, you can still use point-slope form because you can plug one of them in for x1, y1. You can plug the other one in for x and y if you want to find what m is, and then plug it back in. So it's really, really, really important. You could also calculate slope using y2 minus y1 over x2 minus x1, but really important that you know point slope form. All right, so if, let's say, you're given an equation in point slope form and you're asked to graph it, so let's say that I have y plus 1 equals 3 times x minus 1. If we decode what we're given here, that means that my slope is 3 and a point on my line is 1, negative 1. Notice that we changed the signs here because it's x minus x1, where x1 is the x coordinate. So x minus 1 means that 1 is the x coordinate. Y plus 1 means that this was y minus negative 1. So negative 1 is the y coordinate of the point. So if I go ahead and plot that point, 1, negative 1, so write 1, down 1, here's the point, 1, negative 1, and then use my slope from there. My slope is 3, so that means from that point, I'm going to be moving up 3, 1, 2, 3, right 1, up 3, right 1, up 3, right 1, till I'm off the page. The other direction, down 3, left 1, down 3, left 1, and then connect our dots. Now I know you're going to say, but Mrs. Thomas, can't I just take this equation, distribute the 3, subtract the 1, put it in slope-intercept form? Absolutely you can. This is just a little bit faster, and because you're not doing computation, there's a little less room for mistakes. I do not care which way you come up with the correct answer. So if you just really, really love slope-intercept form and you want to convert these, have at it. That's perfectly fine. All right, another way important for you to know how to graph linear equations is with two intercepts. A lot of times in real life problems, the intercepts have meaning, so they're the easiest points to find. So you can find two intercepts no matter what it looks like. Most of the time when I'm trying to solve via intercepts, it looks something like 3x minus 4y equals, let's say negative 15. No, let's not say negative 15. Let's say negative 12. Not that it always has to come out evenly, it doesn't, but that one would have been really messy. So when we are finding the intercepts, what I want to do is remember to plug in 0 for the opposite letter. So if I am finding an x-intercept, I plug 0 in where y was. And again, it doesn't matter if it's not set up like this. Put 0 where the y was and solve for x. So this drops out, and I've got 3x equals negative 12. So that means that my x-intercept is at negative 4. Now, very important, because there are going to be lots of points where it asks you in lessons, on quizzes and tests, to list the x-intercept. Right here, that's not listing an x-intercept. That actually is the equation of a vertical line. When it asks you to list an x-intercept, you need to write it as an ordered pair, because that's what an x-intercept is. It's a point, a single point. So negative 4, 0 is where it crosses the x-axis. To find the y-intercept, other than to put it in y equals mx plus b form, you plug in 0 for x. So 3 times 0 minus 4y equals negative 12. So this drops out. I've got negative 4y equals negative 12. Divide by negative 4. My y-intercept is at the value 3. It's a y-intercept, so that means y is 3, not x. So that's the point 0, 3. Again, really important that you realize that those are ordered pairs. So then I can just plot those two ordered pairs On these ones, you do not have to continue the slope off the page if you don't want, because I can see your intercepts there. So you can just connect the dots there. All right, last one, and perhaps the most basic one, yet the one that most people tend to forget, and that is graphing an equation using a table of values. This one is so important because you can use it for any type of equation. The equation does not have to be linear. You could have x to the fifth minus 5x squared plus 23 minus x over 2. Any type of equation, you can get parts of the graph by picking points and plotting them. So let's say we have negative 8x plus 4y equals, let's go with 24. So this is our equation. Again, because these are all linear, you could use any of these methods to graph this, but I want to make sure you know that table of values is always an option. So when they first taught you this, they probably taught you always pick a negative, always pick 0, always pick something positive. Yes, that's a good rule of thumb to use. However, if things don't fit, sometimes that doesn't work, and that's okay. You do want to try maybe to spread your values out if you can, so they're not all right next to each other, because it'll give you a better picture. Let's just say that for negative, I'm going to pick x is negative 2. So I can plug in negative 2 for x. Negative 8 times negative 2 plus 4y equals 24. Negative 8 times negative 2 is 16. So 16 plus 4y equals 24. I can subtract the 16 here. Gives me 4y equals 8, which means y is 2. Then, if I follow that old adage that Algebra 1 teachers usually give you, and I pick 0 next, remember that plugging in 0 for x is the same thing as finding the y-intercept here. So if I plug in 0 for x, I get negative 8 times 0, which is 0. So I get 0 plus 4y equals 24. Divide both sides by 4, and I get y is 6. All right, great. So then I want to say pick something positive. So let's say that I want to pick 2, just because it makes a very lovely pattern. You do not have to make a lovely pattern. If I plug in positive 2 for x, I get negative 8 times 2 plus 4y equals 24. This gives me negative 16. Then I have to add 16 to both sides. 24 plus 16 is 40. I've got 4y equals 40. Divide, and y would be 10. So you have a choice here. You could either, because this point would be off of your graph if you were counting by ones, you can either choose to count by twos, or you could choose, say, to pick 1 instead of 2 for your x. So if you picked 1 instead, didn't leave myself much room there, that would give us negative 8 plus 4y equals 24. Add, 4y equals 32. Divide by 4, y is 8. So again, it doesn't matter. If you want to count by twos, great, count by twos. If you don't, pick a different number. You won't always be able to pick a different number if it doesn't work out the first time, but if you want to, go ahead. I also do that to point out that just because you're making a table of values doesn't mean that you should plot the values right as soon as you know what they are. Because if you plotted these two and then you forgot that you could pick 1 instead of picking 2, you'd be off the graph. You wouldn't have your 3 points. So again, your choice there, and there is your graph. We're going to be graphing a lot by by hand this year. You will learn how to use the graphing calculator, but almost every test has a non-calculator part where you have to graph by hand. So these basics are extremely important. Have a great night.